Okay, give me 1 second. Okay, so today we will solve some more graph problems. Yesterday we have solved these two problems: rotten oranges, Pacific Atlantic water flow. So yeah, we were able to solve them without looking at solution. So now we will solve this problem. So this problem is in premium LeetCode. Means we need lot of money. Like I think for premium we need, how much money we need for premium. Let's see. I have I think I have taken previously premium ones. So it's $35. So $35 means nearly 3,000. I think 3,000 rupees per month. So I think it's not worth it. Maybe for some people it's worth it, because you can find lead code problems or variety of problems. Means there are a lot of free problems. If you can solve that problems, then you don't need premium. So let's open this problem. Okay, so the problem says, given a m into n 2D grid initialized, we let's make it to Java. You are given a m into n 2D grid initialized with these three possible values. -1 means water cell that can be not traversed. Okay, a treasure. 0, a treasure chest. Okay, infinity, the land cell that can be traversed. Okay, okay. Fill the each land cell with the distance to its nearest treasure chest. Okay, so I think what we need to do is, we are given this array, and in this array we need to find this big number. This is infinity number. This number's distance from closest zero. Means we need to, for example, its distance, closest distance from zero is, we cannot move here because let's assume it's a wall. Means it's some boundary we cannot transfer. So we will go here one distance, then we will go here two distance, then we will go here three distance, then we go here four distance. But minimum is 1, 2, 3, and then we can go to this 0. So this is the minimum distance. So 3 is the minimum distance from this particular value to 0. So what we need to find is, we need to find for every infinity value, we need to find closest 0 to it. So closest 0 to this value, this infinity value is this 0, which is at distance 1. So that's why we are putting answer as 1 here. So distance of 0 from 0 itself is 0. So what we will gonna do is, we will use BFS. So how we are getting idea of BFS? Uh, f- we are looking at the question, and it's saying that we need to find the minimum distance from this particular 0. So what we can do, we can first find all the zeros and add that zeros to our queue, and then in BFS, neighbor by neighbor, we can transverse the area. So in that way, only closest areas will be targeted with this 0. For example, for this 0, the closest, its neighbor is, its neighbors are node this node and this node. So first we will transfer these three nodes. So this will be at distance 1, this will also be at distance 1. So as we can see, this is at distance 1, this is also at distance 1. And then we can put these nodes into our queue and can go on finding other queues. It's similar to the problem yesterday we have solved. Which problem it was? It was Pacific Atlantic water flow. So it's same as this problem. So wait a second. We can't solve it on LeetCode, so we will solve it here. So this we need to, that our minus 1 is uh, we cannot transverse minus 1, so we are putting across 0, from which 0 will be our source and infinity value will be our destination. So we need to find source to destination values, means from 0 to other infinity values we need to find the minimum distance. Okay, so what we can do, we can use a queue. In the queue we need to store these cells and current distance, so we will solve a store a array into our queue. Let's initialize this queue. So in Java, queues are the basically linked lists. So we have initialized our queue, and we also need track of the visited cells, from 0 which cells we have visited. So let's first define the dimensions of our input grid. So grid dot length will be the number of rows, which is n, and m will be grid dot length. Okay, so we have defined dimensions, we have initialized a queue. Now we need a visited array to keep track that which cell we have visited from these zeros. Suppose we have a 0 and we have infinity in between, and we have another 0. So what we will do, we will put these two zeros into our queue. First, from this 0 we will, in first BFS we will go to this value, and from at the same time from this 0 we go to this value. So we will mark it distance as 1, its distance also as the 1, and we will also mark it as visited. Okay, and we will put these two values, these two cells into our queue. From these cells we will move to this cell, and what we will do, this was our previous distance, we will increment our distance, make distance as 2, and also mark it as visited. At the same time, from this cell we will visit this particular value, so we will increase our distance and mark it as visited. So now we don't have a fear of that moving to this cell or this cell, as we have marked these visited, so that's why we need a visited array. So it will be of type boolean, not int. So first we will put all the let's say zeros into our queue. J smaller than n, j plus plus. Okay, so if our uh, grid's value is 0, then what we will do, we will create a pair. We will add a pair to our array to our queue that will include current index means current cell ij and current distance will be 0. So initially distance will be 0. We have added this to our queue, and whatever we have added to our queue we can mark them as visited, that we have found distance to them. Okay, so this is our first step. Now we need to pop out from our queue. So we will process elements from our queue till our queue is not empty. So queue is not empty till we will process our elements. So the first element will be mm, so the current cell will be queue dot poll. So this is our current cell. Now from this cell we have got this cell, zeroth cell. So from this cell we will find all the four directions. So to find all the four directions, we will define a direction vector. So direction vector will help us to transverse the all the four directions. So this is how direction vector looks. So it can be used in any problem where we need to move into four directions into cell, that is vertically and horizontally. So 0, -1, 1, 0, and 0, 1. So okay, we have defined our direction vector. Now in this direction vector we have four directions. This will be uh, left, up, and this will be down, and this will be right. So for int current direction from directions, so our new adjacent cell will be current cells 0 plus direction of 0. And y cell will be current cells 1 plus, so I this will be at 0th position and j will be at first position. Dir of 1. We just need to add these direction vectors to find the adjacent cell. So now we have new dimensions, means dimensions of adjacent cell. So before adding these, we need to verify them. So how we can verify? Each x should be greater than or equal to 0, and also y should be greater than equal to 0, and our x should be smaller than n, and our y should be smaller than n, and more validations we need before adding it to our queue. So then this cell should not be visited, means x and y should not be visited, and it should not be -1, because in the -1 we cannot transverse the path. For example, from this 0 we cannot directly go to this value. We first need to go to the downward direction, then this, because we have a wall in between which is -1. So we should avoid going to -1. So means it should be a land area. So means our grids xy value should be a area. So here land area is represented by the maximum integer. So maximum integer in Java is defined by integer dot max value. So it will give us a max value of an integer, means it should be equal to the max value. So then only we can move to the adjacent cell. So here what we can do, how we can mark that adjacent cell as visited, that we have visited that adjacent cell, and we are adding it to the queue. So q dot add uh, new int x y, and now we need to increment a distance, means uh, one distance plus from the current cell. So current cell 2, at 2 position we are storing the distance, so initially distance is 0, so we will add 1 to this distance. Current cell 2 plus 1. Okay. So at last what we need to do is we need to return this array, means array containing values, means or distance values, that how much distance we have. So let's define an answer variable. So our answer will be same as of dimension of our grid, and in direction here we can add a check like if our grid's value ij equals to -1, in that case we are inserting -1, so we can insert -1 here, which is answer of ij equals to -1. Okay. And one thing we can do is that will be optimization, we will I think can do it later. So we have put a -1 here, and other than -1 all the values in this answer will be 0, means by default a value in the area matrix or a variable in java are defined as the 0. So we have a -1, and here we can update the value, like we can put that value into our answer, this value, distance value, in our answer also. And at the end we need to return our answer. So this is how our function looks. Grid, initialized a grid with grid 0 dot length, then directions, then our queue, then a visited array, then a answer variable. So these are our variables. So we can define all the variables in a single place. That will not make our code complicated. So also here we need to have m for int I equals to 0. Okay, we are iterating and we are marking 0 as true, and q dot add I is a 0 and -1 is -1. Okay, let's run this function. Okay, cannot find symbol visited. So okay, we are not taking it as visited. Okay, other than this I think we cannot find answer. Okay, Okay, so we need to put x and y value as the current cell. And we need a pair here, okay. Okay, we need to return void. So I think we need to modify the grid in place. Okay. So instead of using answer, we need to modify a grid itself. So we can remove answer. Okay. So instead of answer, we can put this value in grid itself. That will be okay, I think, because we are only moving to the grid.max values. So this will not cause any issue. Wait a second, where we are using answer. Okay, so now we don't need this condition. Okay, so we have two test cases. So these two are passed, I think. Accepted. Okay, so we can submit this. I think this will work. Okay, so we have submitted this problem. They only have 15 test cases. Okay, so we have completed these questions. So now we will do this problem surrounded regions. Okay, so we are given a m into n matrix board containing letters X and O. Capture regions are surrounded. Okay, we need regions which are surrounded. So basically, this is a region. This it's like a island problem. So island represents a region. So this is a region and this is another region. Means cells which are adjacently connected means in horizontal or vertical direction. Uh, that cell form a region. So these cell of form a region. This cell is not part of this cell is not part of this region because it is diagonally present. So it's a different region, and these three cells form a different region. So I think we need to find the region is surrounded with X cells. If you can connect the region with X cell, none of the region cell are on the edge of the board. Okay. Okay, so the question is saying that we need to find the regions. Okay. Introduce it to deleted. Okay. So So the question is saying the cells which are surrounded by this x values should be marked as S. So these three cells are surrounded by all the x values in all four directions. So we are marking these three also as the x. But this cell is present on boundary. So any cell means the region having any cell. So basically the conclusion of the problem is the region having any cell, region of O cells, O value, having any cell at the boundary should not be marked at as X. Okay. So this is the question in one line, I think. That the region which has a zero value at the boundary, we should not mark that region as the X. So this cell which we have marked as the X doesn't have any zero on the boundary, so we are marking it as X. But this cell, this region has a uh, is present on boundary, so we are not marking is X. So the region having any cell at the boundary should not be marked as X. So what we can do here is we can transverse this boundary, and from that boundary we can collect all the O regions, and for that O regions we can run a DFS, and we can distinguish them from other regions. Means any region connected to this boundary O will not be marked as X, so we will first highlight it, and we will then don't mark it as a X value. So I think that will work. So for example, we will take this O and we will mark this as something like -1. Let's say this is a string array, character array, so we will mark it as a, let's say, uh, n value, n representing no, that we will not mark this as a x value, so we will mark it as a n value. So what we can do, we can transverse the boundary, and we can collect all the boundary cells. Okay, let's first define a dimension of this board. Board dot length m is equals to board 0 dot length. So this is a number of rows, this is number of columns in the board. We will transverse this board, and we will only collect the boundary elements. So for int I j is equals to 0, j is smaller than m j plus plus. And what we can do, uh, if our I value is 0, okay, or our j value is 0, means our if our row is 0, this row, and if our column is 0, this column, or if our I equals to n minus 1, if this is our last row, or our j equals to m minus 1, that means we are on the boundary. So this will represent boundary cell. And along with these conditions, along with all these conditions, our cell value means board ij cell is O. This means this cell is present at boundary. So this will give us a cell present at boundary, O cell present at boundary. So from that O cell, we will start a DFS. Means any region connected to this cell will be uh, for that reason we will be not marking that region at the X. So we will run a DFS from this index, this cell ij. We will pass our board. Do we need a visited array? Yes, we need a visited array. So we will pass a visited array that we have visited a current cell. Mark for cells attached to this cell as n. We will mark these cells as n. All the cell attached to the boundary. So let's define this DFS. So we have int I, int j, and this will be our board. Board is a character board. Okay, and visited array will be of Boolean type. So what we can do, we can mark our this ij as true. That we have visited this array. We have visited this, and also we will convert its value to n value. That we will be not marking this as n means no, not marking as x. Okay, so any region which is having a cell at the adjacent cell as on the boundary, we will be not marking that region as the x. Okay, so we have marked this as n. Now we can move into all four directions, so we can use that direction vector. Directions, so -1, this will be up direction. This will be we are decrementing column, so this is the decrementing column, means this is the left direction. Incrementing row means this is the downward direction, and this will be right direction. So we will transverse this direction vector over current direction dir into dirs. So what this loop will do, this will one by one transfer these values. Okay, so we will find our new adjacent cell I plus dir of 0, j plus dir of 1. So this is our new cell. We need to validate this cell. This should be y cell. So what we will do, we will check if x is greater than y and y is greater than equal to 0, and x should be smaller than n. We don't have n in this function, so we want to use this n and m, so we can define them as globally. Okay, we have defined these variables globally. Now we can use them here. So x should be smaller than n, y should be smaller than m, and our cell which we are going to visit should not be already visited. So x and y should not be visited, and its value should be o, means uh, board xy value should be equal to o. So these are the conditions which need to verify. We need to verify, then we can move to the adjacent cell, and we can call DFS for the adjacent cell and pass our visited. So in this way, we will mark all the adjacent cells as the n. So for this particular array, we will mark this O as the n. So we can confirm this by printing the board itself. So let's print the board. Mm, print board of ij. We can put a comma, and okay, at the end we need to return something. Okay, we don't need to return something. So let's see what our board. So we don't need to return, then we can see our board itself. Okay, so this is our board. How we can align it? So let's just copy it. Wait a second. This is our board. We can check the board here. So what we have done, we have marked this O as the n because this lies on the boundary. Suppose if in our input array we have a O here, then this whole region will be marked as the n. So let's take that test case, which O we were talking about. This in the third array, second x. In the third array, second x. We will mark it as O. Then our whole region will lie on the boundary. Means this whole region's cell will lie on the boundary. So in that case, the whole O values will be marked as the n. So we can use this and check the new value. Okay. Okay, so these all the values are marked as n. So in our answer also, so this is our answer. So we can see we are not marking these O's as x value. So n means not marking as x. So wherever we have n, we are not marking that O as x. So now everything has become simple. So what we can do, we can retransverse this board. Okay, and wherever we see O, that means we need to mark that cell as the x. And wherever we see n value, we will revert it to the O value, that we are not marking it as the x, ij as the O. Okay, let's submit this. Okay, we have submission. So this was required from us. So let's see. Last submission was in 2022, which was using approach. It was using DFS, I think. BFS, sorry. Okay. So we have solved these two problems. Now we will solve the course scheduler. So we will take a break, small break. Okay, so we will solve this problem, which is course schedule. So the problem, I think this is a pretty famous problem. It has 17k likes, around 17k. Okay, there are a total of num courses you have to take. Okay, we have to take, for example, two courses labeled from 0 to num courses minus 1. Okay, for example, we need to take two courses 0 and 1. Okay, you are given a prerequisite where prerequisite I is AB indicates you must take course B1 if you want to take course A1. For example, we need to take course 0 first if we want to take course 1. So there are a total of two courses to take. There are a total of two courses to take. To take one course, you should have finished course 0. So it is possible. Okay. For example, the pair indicates that, okay, return true if you can finish all courses, otherwise return false. Okay. For example, means one course is dependent on other. Means, for example, we need to take course 0. Sorry, if we want to take course 1, we need to take course 0. And also, if then suppose we want, then we will go for 0. That let's first take 0 course. Then we see there is a condition then that before taking 0 course we need course 1. So for taking course 1 we need course 0, and for taking course 0 we need course 1. So that will form a loop, means a deadlock. So we are returning false, that we cannot take all the courses. So we need to return whether we can take a course or we cannot take a course. Okay, so we have a dependency. There are a total of two courses to take. So we can have at most 2000 courses which we need to take, and prerequisites length can be 5000. And all the pair in prerequisites are unique. Okay. Then courses you have to take level 1 0. You are given an array prerequisites where they indicate that you must take a course BI if you want to take course A1. For example, the pair indicates that to take course 0 you have to First take course 1. Okay. So here we are having a cycle. So for what purpose we use topological sorting? Is topological sorting. Topological sorting. In for directed acyclic graph is a linear ordering of vertices such that for every directed vertex u comes before v in the ordering. Okay. Topological sorting for a graph is not possible if graph is not a directed acyclic graph. Okay, so a directed acyclic graph means not having cycle. So we can here I think use check whether we have a cycle or not. If the cycle exists, then we cannot schedule all the courses, or we can check whether a graph is acyclic using topological sort. But topological sorting is not possible for a DAG graph. Okay. If graph is not a DAG. Okay. So we need. I think it will work if we detect cycle. So cycle in a directed acyclic graph, and all the pairs are unique. We have courses. So suppose we have a visited array. Let's visited array of size num courses, and for starting from every course we can run a DFS. Means there can be courses which are not dependent on any course. So means this will form a disconnected graph. So that's why we will go for all the courses. Courses. So if not visited of I, then we will call a DFS. And also we need to create a map from prerequisites first. Means to pursue course 1 we need to first pursue course 0. So we can make a edge from 1 to 0. So what we can do, we can create a map of integer and list of integer graph, and we can iterate our prerequisites. And what we can do, we can put into our graph dot compute if absent at preposition pre's. So first course we need to put a new array list. If array list is not present, we will initialize that object and we will add tree of 1. So what this function will do, if no entry for this will present is present, then it will create a add a new array list, and that to that array list we will add this edge from 0 to 1. We have added a edge, so we have created our graph. So we can pass our graph here. We are starting our DFS from ith value, and this is our graph, and we can maintain a uh, locally visited local visited array that will be of size num courses, and also can pass our original visited global visited array. Public void dfs int source, and this is our graph. We can pass this local visited array, we can call it as, and this will be our global visit array. So we can check if our this local visited array already contains, means if we already have visited s, that means it forms a cycle. So this means a cycle is detected. Otherwise we will mark this local visited array as true, and also our globally visited array as true. Then we can call our dfs, means for the neighbors, so we need neighbors. So neighbors will be graph.get at source position. So this will give us the list of neighbors. So suppose we need a boolean to say that this is a cycle, so we can return true if it's a cycle. And if a cycle is detected, then we cannot schedule all the courses. So we can return false that a cycle is detected. If in none of the cases a cycle is detected, then we can return true that no cycle is detected, hence all courses can be pursued. So for the neighbors, we can call the DFS. For this graph, and we can pass this local visit and visited array. And if this call gives us true, that means we have a cycle, we can return true. Otherwise, if none of the neighbor call gives us a cycle, then we can return false that we don't have any cycle. So this DFS function, using this DFS function, we are finding a cycle. What we are doing, we are maintaining a local visited array. Suppose we have a cycle like 1, 2, 3, and again 1. Means one's neighbor is 2, two's neighbor is 3, and three's neighbor is again 1. So how we have a cycle here means how we can detect this code will detect it. So first we will mark our source as this one will not be marked as true, so we will mark it as true. Then we will go to 2, we will mark 2 as the true. Then we will go to 3, mark 3 as the true. When we will going to call 1, we can see that locally it is already marked, so we will return true that cycle is exists. So let's see if this works. Otherwise we have to implement topological sort, I think. Okay. Okay, we need boolean array as the visitor. Okay. So while transversing neighbors, we are getting a null. Okay. Means some courses cannot have prerequisite. Okay, so in that case, we can what we can do default as a default value we can pass empty array list. Let's see. Okay. So first case we are getting true. For second case we are getting false. That first this case has a cycle. So let's try to submit this if this works. Okay, we are getting error in 45th case. Our code is returning false that we cannot pursue all the courses. Let's see why this is happening. So we have this array prerequisites. So first we will form graph. So our graph will look like against 1 we will have 4, against 2 we will have 4, against 3 we will have 1, against 3 we will have 2. Yes, we can use topological sort, but I'm trying to solve it using uh, DFS itself. Don't know why, but what a topological sort does means topological sort is valid for directed cyclic graphs. Means it will not run in cyclic graph. So I am using this statement itself that I am checking if it is a cyclic graph. We can use topological sort also. Means we can calculate in degrees to each node, and we can start from the node having in degree 0. So in that way we can use topological sort. Intuition. So 3 will have 1 and 2. We can check for which part it's failing. So it's failing for 3. So why it's failing for 3? Suppose we call for 3. 3 have a prerequisite 1. Okay. From 3, we will mark locally 3 as true. Then we will go to 3's neighbor. First we will go to suppose 1. Okay, I think we are doing a mistake. That is, we are using zero based indexing to mark arrays as visited, but here courses. Okay, we have 5 courses. Indexing is correct. So we are not using zeroth course here. So we are getting error for third course only. So for 3 we are going to 1. For 1 we are going to 4. Okay. From 2 we are going to this 2, and we are getting this 4 as already marked, but this doesn't represent a cycle. Okay, means from this 3 we are going to this one will go to 4 and mark this 4 as true, then this 2 will go to 4 and it sees that 4 is already marked and it returns true, and cycle doesn't exist here, so that's why we are getting wrong output. So what modification we can do here? Yes, this is happening, means one is marking 4 as true and 2 again seeing 4 as the marked, so that's why the code is failing. So do you have any suggestion to make it correct? Or should I ask GPT? Okay. So can't we do like this? We can mark this locally visited at false once we complete that, uh, what we can say, complete that DFS for that particular source. So use path. Path means it's working, means we are yes, yes, I'm backtracking. I have added the backtracking check. So let's see if we can submit it. Getting TLE for this approach. So I think we need to use topological sort. Sir, no visit is it different and path array is different. This is I'm using this local visited array as the path array, and this visited is globally visited. Bro, I'm 23 pass out. Okay. Mm, uh, Let's see if we can get optimized version of this. Otherwise, we can go with topological sort. By removing redundant visiting nodes here, the active. I think this doesn't improve time complexity. This particular thing. Okay, so we can first try this solution, then we can move to the console algorithm. If it works, we can see how this is working for this case. Okay, so it is working, so we can optimize that solution which we were implementing. So it's taking a single state, means one for visited, two for fully processed, and zero for unvisited. So how we can compare our solution? So this was our solution. So here what we are doing, we are having a array. Initially it's unvisited, then uh, one is visiting and two is fully processed. So if its state is zero, means if it's unvisited, then we are calling DFS. So similar thing we are doing here. We have visited array, and if it's false, not visited, then we are calling DFS. Wait a second. What some solution we have submitted? I think we were getting TLE because of this print statement. No. Okay, so then we are taking state and checking if state is one, means if it's visited, then a cycle is detected. So If it's not given as DAG, check for the cycle in DAG. If cycle exists, it's definitely return false. Let's go for topological sorting. It is not given as DAG, so let's check for cycle in DAG. So here we have one more check, means we are not revisiting the array which we have revisited, means which we have fully revisited. So I think we are missing this check, means we are missing this check, means if it's already visited, then we can return false that cycle does not exist. I think this is the only check, means we don't need to reprocess the nodes which for which we have already अरे bro, how can I learn DSA यार, मेरे को नहीं आता खुद को. ठीक है. So I think we were missing this case. So let's see. So it's working. So we were missing this statement. We were reprocessing nodes, visited nodes. Okay, so this is the code for Khan's algorithm. So I think for topological sorting. So we can solve that question using topological sorting also. So I use this algorithm to implement topological sorting. This has a this approach basically first calculates the in degree. In degree means incoming nodes, and then adds that all the nodes with in degree to a queue, and then one by one it processes the nodes with the in degree 0, and what is it's doing. Then for the adjacent nodes, it decrements the in degree by 1 and checks if adjacent nodes in degree have become 0, then it adds to the queue again. And we are taking a variable index plus plus. So if that variable at the end doesn't become equals to v, means v here is a number of nodes, I think. Number of nodes. Okay. Okay, I have this pinned. So where I can find this particular problem in A to Z sheet. Sidebar. Okay. A to Z sheet है ये. Hmm. Graphs. VFS, GFS, shorter path menus. Other algorithms, I think. Kosaraju, Topo short, Khan's algorithm, and its article difficulty in practice. Hmm. Topo short. So graph may have multiple topological sortings. The result is one of them. The necessary conditions of the orderings are here. All the necessary conditions is also one such topological. Are you in college? Sai. College staff. Which year, which college, and which branch? Third year. Okay, nice. Hyderabad. CSC. So I think now you will be having a placement season, means or in the next semester, I think. Okay. The topological sort protonode. Okay, we are means while doing DFS, we are just at the end of the call, we are adding the node to the stack. So and then we are popping out all the elements from the stack, from the stack, and adding them to the this variable, I know for that topo Khan's approach will be used. Reversing the stack basically. Can't we copy this code somewhere? Okay, so we have this graph, and for this graph, we are calling this topo short, creating a array of in degree. hmm You are right. First, we are calculating in degree. Then we are adding to the array the nodes which have in degree equals to 0. And now we are processing one by one from our queue. So we have removed a element having in degree 0. Then what we are doing, okay, so this is a array. Hmm. In degree 0 are independent nodes. Okay. Then we are removing them from our node. Bro, I woke up at 7, and then I got ready for the office, and I have just came at 7 from the office, and I have start streaming from them. Okay. So this is, I think, returning ordering of the nodes means the order in which nodes will appear in topological sorting means this array is used for that purpose. No, I'm not serious. I'm just saying that's why I'm getting blank. Okay, so this, and then we are decreasing in degree of its neighbors, and we are putting the neighbor whose in degree becomes 0. And if we find the full topological order, means then we can say we have this is a DAG graph. So we can implement it this approach also. Just give me a minute. Okay, so after implementing this approach, we can end our stream. Today, one of the member from our viewers, Sai, distracted me from solving the problems. So that's why we are getting late. So what we need to do first, we need a graph. We need to create graph. So this will be source, and this will store neighbors integer. Okay. So this will be our graph. New hash map. Why don't we just pick our last submissions 17 minutes ago? Okay, this is the graph. So we have calculated our graph, and we need a array to calculate in degree of all the nodes. In degree, in degree will same as the size of the number of the nodes in the graph. Now we need to transverse our graph and need to calculate the in degree. So to transverse the graph, what we can do? Okay, we don't need to transfer graph. We can just pop out elements from it, like num courses I plus plus for in degree. So from this node we will be going to other node, means for other nodes, for neighbor we need to find the in degree. Okay, for neighbors we need to find the in degree. So this is our graph. Graph dot get I. Okay, or default in the case we don't have it in our graph. We will increase in degree of our neighbor. Okay, now we need a queue. In queue we will be putting nodes with the in degree 0. So let's make a queue of integer. So for int I equals to 0, I less than ni plus plus. If in degree of this particular node is 0, in that case we can add it to our queue dot I. So now we will process these nodes from our queue while our queue is not empty. So our current node will be queue dot poll. Now what we need to do, we need to iterate this node's neighbors. So this node's neighbor will be similarly like this. We will iterate its neighbors, and for each neighbor we will decrement the in degree of that neighbor. And whenever in degree for a neighbor, wait a second, whenever the in degree for a neighbor becomes 0, we will add that neighbor to our queue. Okay. So initially we have in our topological sorting found the nodes, means the count of the nodes, means how many nodes we have added to our sequence will be 0. So after processing this, we can say that we have processed a node, so we can increment its count. So at the end we can check if we have processed all the nodes. So if we have processed all the nodes, that means the graph has no cycles. It is a directly acyclic graph. Otherwise, if we haven't processed all the nodes, we can say that the graph is not a DAG. So I think this is it. So this is Khan's algorithm to find what we can say topological sorting. Prerequisites, the number of courses in degree added within degree 0 to the queue. Okay, count equals to 0. For neighbors, we have decremented the in degree. Count plus plus number of courses. Let's see if this works. Okay, we don't have n here, so it's the num courses. Okay, okay, it's working for this case. Let's check if this case is working. This is working. Okay, okay. So we have implemented Khan's algorithm to find this code schedule, means to solve this problem code scheduler. Okay, so I think that is it for today. We have solved these two problems and these problems. So we have solved three problems today. So tomorrow we will target these three problems. Okay, thank you.